Hello everyone, this is Mrs. Padmashri from SNS College of Engineering. Today we are going to discuss about the continuation of the ResNet architecture from convolution neural network, which comes under the subject of deep learning. Already I had given you the introduction about what is a REST network and what are all the layers present in the ResNet. And today we will discuss in detail about the architecture of REST network. And uh, in the previous lecture, I had discussed about what is a ResNet. It's a deep learning model used for computer vision application, and it is a convolution neural network architecture mainly designed to support thousands of convolution layer. In short form, we say it is a ResNet, residual network type of neural network introduced in 2015. It was designed to solve the problem of vanishing gradient in deep neural network, right? So which has the performance of large scale image recognition task. This is a challenging one. There are several layers are present in the ResNet architecture. So today we will discuss about in detail about what are all the layers we have in the ResNet architecture, and the residual blocks will be present in the ResNet architecture, right? So, what is this residual block? It's a set of layer that perform a set of transformation on the input to obtain the output, and it includes a shortcut connection that adds both the input and output. Okay? The ResNet architecture has several variants, including ResNet 18, 34, 50, 101, and 152. The number in each variant correspond to the number of layers in the network. So if I say 18, ResNet 18, there will be 18 layers present in the ResNet architecture. And ResNet 50 has a 50 layer, 152 has 152 layers. So the architecture that we are discussing about is this ResNet architecture. Is displayed in the slide. It has this has a ResNet 50 model architecture. As we already know, the ResNet has input starting from this left side. We have the input, and the last right side will be the output. There is a zero padding. Then we have the convolution layer, batch normalization, and RELU. Okay, we have already rectified enable linear unit max pooling layer. We have the convolution blocks, ID block, convolution block, ID block. Like that, we have stage 2, 3, 4. Okay, all these stages has convolution blocks, and stage 5 also. Sorry, stage 5 also has a convolution block. So this continuous block, we say it is a set of residual blocks, or we say it is a stack like architecture, right? Stack like convolution layers present in the ResNet architecture. Okay, and it has an average pool, flattening, and FC. We know that fully connected network which is present in ResNet also, right? And the rest will be the output. So these are all about the ResNet architecture. ResNet architecture. Already we have discussed about the functionalities of each and every layer, right? So in detail we see this ResNet 50 architecture is one of the most popular variant. Has 5 stages. Each contains the residual blocks. First stage has convolution layer followed by max pooling, which reduces the main functionality of pooling, which reduces the spatial dimension of the input, and it retains this features as it is, and the dimensions of input will be reduced. The second, it has 3 residual blocks, each containing 2 convolution layer and a shortcut connection. Third, fourth, and fifth stage contain 4, 6, and 3 residual blocks respectively. So each block in these stages contains a several convolution layer and a shortcut connection. Output, the last will be the output The output of the last stage is fed into the global average pooling layer. So the main functionality of pooling layer reduces spatial dimension of feature maps to a single value for each channel. It just reduces the dimension and it channelize a single value will be reaching to the next layer. So output of the global average pooling is fed into the fully connected layer with softmax activation, which produces the final output of the network. So these are all the main layers present in the REST network. This RESTnet is an important network architecture in convolution neural network because it overcomes the drawback of uh, it overcomes the drawback of the this we have already discussed, right? Overcome the drawbacks of VGG network. VGG network. So we have the applications here, and the application of these REST network mainly is used in deeper networks. Then it is having the improved accuracy compared to the VGG net BGG net. Um, so it overcomes the dropout problems, right? So the application has improved accuracy. It has the accuracy of the network is improved, and which has a faster convergence, and which has a transfer learning. So these are all the important applications of ResNet. Thank you.